What we are interested in now is determining for an infinite series for what values of x does this series converge. So that means when is that sum going to add up to a number, or if we look at a graph, when does our polynomial that we create match up to that function? For what values of x does it converge? For a geometric series, it's pretty a little bit more straightforward. Basically, we learned that a geometric series only converges if the absolute value of r, which is the common ratio, is less than 1. So we can find that r pretty easily, then we can find that interval of convergence. So in this problem, notice that your r, your common ratio, is x minus 3, because that's what's being raised to the nth power. So we know that this is only going to be equal to a sum, so it will only converge when that absolute value of r is less than 1. So we can solve this inequality, and this is what's called our interval of convergence. Now, the other thing that we're interested in is also what's called your radius of convergence. So your interval is an interval of numbers. Your radius of convergence, we're going to use capital R, is actually one number. And basically, it's, if you think about your number line, so we're going from 2 to 4. What's the center? In this case, it's 3. And how many units are we going in either direction? We are going 1 unit in either direction. So this is called our radius of convergence. Now, if you want to just find your radius of convergence, you can actually find it just from this piece right here. Because I know what the center is, right? Anything in the form x minus c, this number, 3 in this case, is your center. And this is going to tell you how many units that you need to go in either direction. So my radius of convergence I can get from here. But in order to get to the interval, you would have to solve that inequality. So same thing here. This is a geometric series, right? Because all I have is things raised to the nth power in numbers. Your r in this case is just x over 3, because that's the only thing being raised to the nth power. So we know it converges if the absolute value is less than 1. I can go ahead and take that absolute value of 3 and multiply it over. So this is my interval of convergence. So my radius of convergence, right? The center is 0 and you're going 3 either direction. So your radius of convergence would just be 3. Now, one thing to note about a geometric only converges when the number is less than 1, so your inequality should never have an equal sign, right? When it's equal to 1, it will diverge. Okay, now what if the series is not a geometric series? Then we have to do something else. This is when we're going to use our ratio test, because that's the only other test that gives us an inequality to solve. So the ratio test, if you remember, tells us that if we take the limit of the absolute value of the n plus first term, so plug in n plus 1 wherever there's an n, divided by the nth term, so I'm just going to go ahead and turn it into a multiplication problem. If this limit is less than 1, I know that this will converge. So we need to find this limit first. I'm going to clean a couple things up. So this piece here, remember, this is really x to the n times x to the first, so the x to the n pieces will cancel. So I'm really left with an x on the top. And then same thing happens here. Really, the 3 to the n's will cancel, so you're really left with just a 3 to the first on the bottom. And then notice I do still, oh sorry, I forgot to put this n in the original problem. That I still have the n and the n plus 1. Now, if I take that limit, the degrees on the ends are the same, so the limit of this becomes 1, so the only thing that you're left with is x over 3. So this is my limit using the ratio test. Ratio test says that it only converges if that limit is less than 1, so this is what we're solving. And for right now, when we use the ratio test, let's say I only care about the radius of convergence. So radius of convergence in this case is going to be 3, right? The center is 0. I mean, think of it like this, and you're going 3 either direction. Okay, try the same thing with the next one. So I'm going to set up my ratio test. Again, if it is not a geometric series, and it's not because I have this n squared on the bottom, the only way to find interval or radius of convergence is to use the ratio test. So the n plus first term, divided by the nth term. And we're going to simplify this very similar to how we did before. Again, this is going to leave you with x minus 1. I still have the n squared, n plus 1 squared. But notice degrees on the n's are the same again. So your limit, now we've taken the limit, we don't have to write that limit statement, is x minus 1 only converges if it is less than 1. Again, I don't need to solve this inequality. The center is 1, right? That's what that x minus c tells us. And we're going 1 in either direction. So if you have the inequality in that x minus c format, this is going to be your radius of convergence. Now, if you solve it, I mean, you should notice the same thing, right? Center is 1, you're going 1 in either direction. But this we don't need to do if all we're finding is the radius. Okay, let's do the last two. Same thing, I'm going to set up my ratio test. The n plus first term, divided by the nth term. I'm going to turn it into a multiplication problem right away. The negative ones are going to become unimportant because the absolute value of negative 1 is always going to be 1. So it really doesn't matter that that's there. I'm going to clean this up a little bit. We have x to the first on the top. Now let's look at the factorials. Remember, this is really n times n minus 1, n minus 2, dot, dot, dot. This is n plus 1, n minus 1, dot, dot, dot. So notice all of this drops out, and all you're left with is an n plus 1. Notice you still have n's, so now when I take this limit, the n is only on the bottom, that your limit is always 0, regardless of what x is. Remember, ratio test says it only converges if this is less than 1, but we always get 0 for this limit, which is always less than 1. So this is going to converge for all values of x, right? This limit is always 0. So our interval of convergence is actually negative infinity to infinity because it's every single number. So then your radius of convergence, the center of this is really 0, but you're going infinity in either direction. So this is a special case. Okay, last one. So set up our ratio test. Divided by the nth term. And again, let's clean this up a little bit. So I'll have an x on the top. When you simplify the factorials, you have an n plus 1 just on the top. So this is all we end up with. Notice here, the n is only on the top. So if I plug in infinity for n, infinity times anything is always infinity. So this is always going to be infinity. So this is our other special case. Infinity is always bigger than 1. It's never less than 1. So you would think there is no interval of convergence, and there isn't, but there is one value. So my radius of convergence is actually 0. You're not going any units either direction. But there is a number for which this series converges. There's exactly one number. And it's basically whatever makes this 0. This would only converge at x equals 0. Because if I plug in 0 for x, everything is always 0. So you end up with 0 plus 0 plus 0, which would be 0.